Hello everybody. So I thought it's time for an update. Now first off, I need to get some steel laminations cut for my new solid state generator device because the coupling is very poor. So bear this in mind when I'm going to show you something in a minute, but bear this in mind, there's 70% efficiency lost. I know that because I use my magnetic gauge to check the flux. So basically, when I put the gauge next to a magnetic field, it deflects this gauge by a certain amount. Okay, right. So based on that, this gauge, when the magnet was, this end of the magnet down, this ball bearing down at the bottom was actually pressed up to about here with the full strength of the magnet. When I was testing it after it had been through the cores, it was deflected about here, so I lost most of the flux in these corners, because the corners I haven't built them yet for the I'm going to get laser cut ones, so it's going to be a while before I get that done. So I'm actually using the ball bearings, so I decided, let's just try it. It's not finished yet. It's on its side right now. Actually, it shouldn't be. It's a bit precarious being on its side, and I've only got one coil. Bear in mind, one coil. There is no coil down here. There's nothing wound on it. It's just empty bobbin. And I thought, I'm going to see what it does. I'm just curious. So I got my driver circuit out. Now this is where it gets. This is where the fun starts. This output coil. This output coil is not even the right. It's not even got the right wire on it. It's got a 1.6 ohm DC resistance on this coil. It's pretty hefty wire actually. It's quite thick wire. And it's pushing out only 2.78 volts AC, right? And we're driving it with 150 milliamps right now. But this is where it gets quite interesting, is if I switch my meter across to current, we are pulling out 72.5 volts, 72.8 volts, sorry, 72.7 milliamps in current, 72 milliamps in current, right? And the input current hasn't changed. And just to show you what I'm about that, let's flick it over to hertz. Right, we're on hertz now. And input current hasn't changed. So let's go. Oh, that's the hertz. So 985 hertz. Well, just under a kilohertz actually. Right. So yeah, and I haven't got my oscilloscope hooked up to my H bridge at the moment, but I haven't checked the waveform on it. Actually, I need to do that. Let me just get my. See if I can get my oscilloscope hooked up. I need to get this thing turned on. Which one is the right lead? That's the one I want. I'm having to step over a load of wires here. I've got this trailing wire I've got to step over, it's a pain. So I need to hook this up to the output pulse. I don't want to be hooked up to the coil because the coil is going to give me a lot of spikes and things. So I've forgotten where I connect this to now. Oh yeah, the input voltage I'm sending in is at the moment is 40 volts. I can go way up in voltage because it's a very narrow pulse train. Oh my god, my MOSFETs are getting pretty warm. Jesus, I didn't realise they were getting that warm. Yeah, I might be, yeah, it's getting quite hot actually. I don't want to blow my MOSFETs up. That's getting pretty hot actually. I'm going to turn it up a minute. Because I haven't set this up properly and I don't want to blow my MOSFETs. They're a pain in the ass to change because there's 4 of them. I need to, oh, where the heck is my signal? I've got some test points. I forgot where they are. Oh, it's down here. Right. My test points are down here, so I want to be that's my ground. I can't remember. Oh yeah, I know where it is. Clip that one on there, and I've got some. I built this thing a few years back, and I've forgotten where I put my test points. They're actually down there. So hang on, I put the ground lead on last because I'm trying to. Yeah, I can see it. I can only test 1/2 at the time though. At the moment, I could actually put both on. Let's just turn it on, see what gets on the scope. Right, there's my signal. Oops. Stay on. I haven't set this up yet, so hang on a minute. There's my. Let me just get the get this in the right position. Oops, wrong one. I want that one. Right, there's my pulse train. That's half of the pulse train, by the way, because there's 2 test points. I need to click the other one on the other one. Just a minute. Right, I'll just click this on the other test point. You can't see it. Where are you? Looking down here somewhere. I think I can see it. Don't short anything out. Right, there we go. There's my other pulse train. Right, let's get this in the right position. Right. Wrong one. Right, so you can see the dead time. There's a certain amount of dead time. The dead time. I ain't got it on here. I haven't got the dead time. I need to set that up. The period. Oh, well, the period is. Where's the period? 1 millisecond. So yeah, it's at the bottom. Period is 1 millisecond on the pulse width at the moment. Oop! I tripped off. I've knocked my thing off now. I need to set this up because if I tune this right, the pulse width will go higher. Let me just. It's probably because I haven't got a proper. When I set this just right, I get a higher voltage on the output. Oh, I'm actually not. I want to be on current voltage. I mean, hang on a minute. Get my pulse width right. I need to get a little fan blowing on them MOSFETs. It shouldn't be getting warm anyway. Well, right, let's adjust the freak. Oh, I'm down to 50 milliamps. Look at that. Down to 50 milliamps now. Voltage is dropping. 70 milliamps on the input, 60 milliamps on the input right now. Oh, at 2 point. Let's adjust the frequency. I'll move this on the voltage so we can see. I need to put a different capacitor in my thing. Right, we're at 50 milliamps on the input volt current. I'm at 2.83 volts at the moment. Let's switch to current. No change. 44 milliamps on the output on current. Back to voltage. Yeah. Let's go to a really low frequency. I'm really low now, you can see it. The voltage has dropped off to virtually nothing. We're still at 50 milliamps, look. This is getting pretty toasty actually. When the MOSFETs start to get hot, it's a bad thing to let thermal runaway take over. So what I'm going to do is I'm going to turn this off for a minute or two. I'm just good because I want to find another capacitor. That's 100 nanofarad. So I want a 47 nanofarad. Let's have a look, see if I can find something a bit smaller. Or even maybe a 10 nanofarad. Let's see, what's that? That's 100. What's this one? These orange ones, I've forgotten what they are. Trying to jiggle it around a bit. It's upside down, I think. I can actually see it better on my phone than I can with my eyes. Maybe. Or maybe not. Oh, I can't see it. Anyway, I'm gonna try it. I need to go rummaging around in my other component box really to find some better capacitors. Let's pull this 100N out. The legs are too close together on this thing. Hang on. I'm trying to hold the phone while I'm doing this. Stupid legs, come on. Hang on, I can't do this with one hand. Just give me a minute. Oops, phone sliding around. Just give me a sec. Right, oops, the phone's slipping. Right. Let's plug this one in. These legs are a bit loose. Right, let's switch that on. That's very high frequency. Out of range. Let's turn it down a bit. Nada, nothing. I'm not even getting anything on the oscilloscope right now. It wasn't connected, that's why. These legs are crap. Let me just straighten these legs out just a minute. I hate these orange capacitors because the legs are just too close together. Even my phone's getting toasty now. Right, that should work better. Damn it! Stay on, you bugger. Crap. It's not connecting properly in this socket. Probably dirty legs. I'm getting really angry now. It's been a right bitch. Come on. A stupid thing. It's probably the right range as well. If I can stick a bit of wire in with it, it might make it stay connected. I'll get this. Let me just get this other capacitor. Stick a leg in. That's not going to work. Which one is it that's not working? It's that one. It's this leg on the left. Oh. I could coat it with solder or something. Hang on. That was it. This capacitor's just a piece of. Hang on a minute. I'm going to zigzag the leads a bit. What's going on? Is it still alive? I don't know what's going on. It keeps twitching at me. This swine. Cheap crap. Okay, it's connected right now. I've spent all that time just trying to get it connected. Just have to be careful I don't knock the damn thing. Right, oh my god, 260 milliamps, that's way too high. Current's coming down. But the output voltage is going... Actually, no, it's going back up again. 4 volts. 120 milliamps. Current's going up again on the input. Let's just tweak it for minimum current. Let's go down to where it was. Where was it? Around about there. Seems to be seems to be around, what frequency is that? That's 1.9 kilohertz apparently, according to this oscilloscope. And we're at 90 milliamps, 80 milliamps, 80 milliamps, and the output voltage of that is 3.27 volts AC. Obviously there's not many turns on this coil, and it's heavy duty, it's pretty thick wire. And don't forget, this isn't finished yet. These ball bearings, there's a huge loss on them, and I've got my cores done, the parts that go in between, but there's a lot more work to do with the right angle couplers on here. So, and there's a lot of loss between, because I've also got ball bearings between the coils down here and the actual corners up here. So there's losses in that ball bearing as well. Well, in all of it, there's 4 ball bearings. So every ball bearing has got something like, well, these ones that are closer to the coils will have a less of a loss, but there'll be about 20% loss because they're so close to them. But the corners are 60%, 70% loss because of the corner, because the magnetism is going out in all directions, as you see. So it's not focused around the corner into this coil, so a lot of it's going out in all sorts of different directions. So let's see what current. Now remember, we're 80 milliamps on the input current. Let's go to output current, shorting it out. We're actually drawing out 85 milliamps. Input current, let me just turn that current on here off while I do this. Oh, what? 10 million? Oh no, it's not, no change. There's no change. Oh, 1 kilohertz, right, go to current. No, there's no change. We're back on current, and the input current hasn't changed. Back to kilohertz. It has dropped a little bit, maybe. Let's put it. Oh no, it is still at 90 milliamps. It's just in between. Back to current. Maybe it's using 5 milliamps more. Back to kilohertz. Current. Kilohertz. Right, there's a slight amount of, and that's on kilohertz right now. Back to current. So yeah, it's drawing a bit of current out. It's at 85 milliamps out at 3.3 volts, 3.28, 3.3 volts. Yeah, right. Interesting. That is very interesting. And I'm on volts right now. Look, it hasn't changed because it's still hovering. Look, it's going up and down between 90 milliamps and 80 milliamps. So the input current is still the same when it was loaded. I'm on volts right now. Current. Yeah, I'm not seeing much of a difference. 85 milliamps. Back to voltage. Yeah, there's a slight dip, but that's, oh God, that's nothing, is it? I mean, we're only pulling out 80 milliamps. Yeah, that's really interesting. Yeah, well, I can't wait to get the get this thing finished. Actually, I'm gonna knock my time base up there's some discrepancies with my driver circuit. It needs to be sorted out on my H bridge. I've got some little blips there which are obviously causing heat in my MOSFET, so I need to get them sorted. I'll leave it on there. So the frequency 1.9 kilohertz, peak to peak. Oh, forget the voltages, because I'm measuring it directly from here. It's nothing to do with the output of this coil. The voltages are coming directly from the driver circuit down here. So yeah, you can forget the voltages. That's irrelevant. That's not the output. We're just checking the drive circuit. So the frequency is 1.9 kilohertz. Yeah. All that's interesting is the period, which we're currently on 524 microseconds. There, at the bottom there. Right. Anyway, I hope you enjoyed this little update. Because let me check the temperature on MOSFETs. Actually, they're running cold now. The temperature is a lot better. Let's check the temperature with my temperature thingamajig. 33. Yeah, that's good. Oh, actually 40. So they're actually. You want to point it further down there. 40C. That's now. Yeah, they're running cool now. That's a lot better. I don't want to. Obviously, I don't want to overheat my MOSFET. But this heatsink is not very efficient. It's just a piece of steel. It's very inefficient. I really need to make a heatsink out of copper. It would have a much better thermal mass. I've got some copper somewhere. I made this heatsink ages ago. But anyway, I thought it would be interesting just to see the, let's just say the beta version, because it's not finished yet. I mean, it's very ad hoc. I went and accidentally knocked this earlier and all my ball bearings fell out because this thing's adjustable. I can slide these up and down. If you slide this up, well, that's why I've got elastic bands around it to hold it together. That's how bad it is right now. So I accidentally leaned on it when I was soldering these wires on. I just put a bit of pressure on and the whole thing just went, it flopped to the side. My center magnet concentrics fell out and the whole thing just literally fell apart on me. It was kind of funny actually, but it's the wrong way up at the moment. It's supposed to be, do I move it without these might get touching? I don't know, let's just see. No, I'm going to leave it. These want pushing together a bit, but I can't do it when I'm holding the phone. Anyway, so yeah, there's a lot more to do. There's a lot more tweaking to do. I've got to actually specifically wind some coils that will match up so I can get more volts. I need to get something like 12 volts or at least AC. I need RMS at least so I can use the output voltage to do some useful work, because at the moment 3 volts is pretty crap. I could probably run a clock with it. Probably run 2 clocks with it actually, but yeah, that's a bit pointless. Yeah, but anyway, it's as I say, it's very basic at the moment. There's a lot of work to do, and these drive coils are completely ad hoc. I mean, these 2 coils on here, the top one and the bottom one, you can see underneath, these are very low impedance. Well, there's a difference of something like 400 turns between these 2 coils and these 2. So these are off my old project, so I just basically grabbed a couple of 4 coils that I had kicking about. So they're not even being wound properly for this thing. They want to be all the same. So ideally these coils need to be all exactly the same. So yeah, I really need to wind some more coils, or find 4 that are exactly the same. If I can find 4 identical coils, then I'll be a lot better off. Things are more in balance, because at the moment things are not balanced on this thing. Well, yeah, we're having fun. I mean, that's pretty impressive actually, 80 milliamps. I mean, it's solid state, so I'm not moving physical mass, so that's probably why. Anyway, see you later.